All right, here is a quick walkthrough of the Chapter 15 test. And we start with these first two. They are, of course, volume of cylinders. The volume of a cylinder equals pi r squared, which is the area of the base, times the height. So for this first one, it'll be pi 2 squared times 3. 2 squared for the radius and 3 for the height. I'll let you figure that one out. And then number 2, just different numbers. And don't be fooled, it's not the diameter that we want, it's the radius, so half of that. Volume equals pi 5 squared times 6 is how you'll get that. Don't forget that the units would be cubed. For the next two, which are cones, we use volume equals 1/3 times pi r squared times h, just like we did with the pyramids and prisms, same with the cones and the cylinders. So 1/3 the volume. So for this number 3 here, it would be volume equals 1/3 times pi 6 squared, because the radius is 6, times 7, because the height is 7. Figure that one out. Remember, multiplying by 1/3 is the same as dividing by 3. Over here for number 4, volume equals 1/3 times pi 6 squared, because just the radius, not the whole diameter, radius, times 4. And again, that multiplying by 1/3 is the same as dividing by 3. For number 5, we're doing the volume of a sphere. And the volume of a sphere is 4/3 pi r cubed. So 4/3 pi r cubed. So the volume of this sphere would be 4/3 times pi times 9 cubed. And remember, 9 cubed is definitely not 9 times 3. It's 9 times 9 times 9. And when multiplying by 4/3, it's the same as multiplying by 4, but dividing by 3. Okay, so make sure you get that whole thing done for the volume of the sphere. For number 6, it says find the missing dimensions of the solid. So here, it's a cylinder, so volume equals pi r squared times h, but they give us the volume. So now the volume is 1,215 pi equals pi times 9 squared, because the radius is 9, tells us right there, times the height. And you'll solve for the height. So remember, what that means is you simplify the right-hand side. 9 squared is 81, so this becomes 81 pi times h. Divide both sides by 81 pi. And that'll give you your answer. Height equals, and then simplify that. It does go down to an integer. Obviously, it'll have to be positive. Over here, same kind of problem where you have a missing dimension. So you'll simplify. This side can't really be too much simplified. You just have to divide by 4/3 pi, or instead of dividing by 4/3, remember that's the same as multiplying by 3/4. Now I like to take that in 2 steps. I would divide both sides by pi right away, just to get rid of pi and not have to worry about it. 288 equals 4/3 times radius cubed. Well, now you can just multiply both sides by 3/4. So I'll put it off. Instead of working vertically, go horizontally this time. So times 3/4 times 3/4. Remember, that's over 1. So these will cancel. 3/4 times 4/3 is just 12/12, or 1, leaving you with radius cubed. And then over here, we could actually simplify this. 4 goes into 288. It'll go into 28 7 times, and then 8 twice. So 4 goes into 4 once, 4 goes into 288 72 times. Well, now you just multiply 3 times 72 to get 72 times 3, 216, 216. Take the cubed root of each of those. The cubed root of r cubed is obviously just r, so that's the radius. And you have to figure out what cubed is 216. Again, it's just a whole number. And something times itself again will give you 216. You can figure that one out. That was number 7. For number 8, these are composite solids we're finding the volume of. So for number 8, you've got a cylinder with a cap of a half of a sphere on each side. So you put those two halves together, you obviously have a whole sphere. So we're going to find the volume of the cylinder right here. Volume equals pi r squared times h. Plugging in the information, we have pi times 3 squared because times 6. The height is 6 because you're just doing the height of the cylinder, not of the whole thing. So that's 6 because right here is 3 and right there is 3, leaving 6 for the height of the cylinder. So you'll figure this out. 3 squared is 9, so this would be 9 pi times 6. Figure that out. And then for the sphere, it's 4/3 pi r cubed. R is the radius, which is 3. 3 times 3 is 9 times 3 is 27. So I have 4/3 times pi times 27. Now remember, multiplying by 4/3 is just dividing by 3 and then multiplying by 4. So divide 27 by 3 and you get 9. And 9 times 4 is 36. So that gives you 36 pi. When you're all done with this, you multiply this to get that answer and then add it to this to get the total volume of this other composite. A little trickier. You haven't seen one like this yet, but that does not mean you can't do it. This is a cube with a hole drilled in the middle. So we're going to have to subtract off that volume. So for the volume of the cube, it's just base times height, or 8 times 8 is 64, times 8 to give you the volume of the prism. Over here, for the volume of the cylinder, pi r squared times h, you get pi 2 squared times 8. And then when you get this, so 64 times 8 is 512. And this 2 times 2 squared is 4. So 4 pi times 8 is 32 pi. Now you cannot actually combine these. So you will literally just show this one as 512 minus, that is a ginormous minus sign, minus 32 pi. And then you'll put that in parentheses, and the units would be inches cubed, okay? So 512 minus 32 pi inches cubed would be the volume of that one. So I kind of did the whole thing for you there if you were paying attention. For number 10, we're just, do these two cones, are they similar? Do they form proportions? So I took all of the dimensions from the smaller one, put them on the top of our ratios. 9 for the radius, 12 for the height, 15 for the slant height. You put the corresponding dimensions here underneath and see if they do indeed form a proportion. If they do, the answer is yes. And if they do not, well, then the answer is not yes or no. So for number 11 and 12, these are similar. So we know they form proportions. Here we're just talking linear measures, so it's just a regular proportion here. 6 radius over radius, small over the large, so 16 over b, height over height, 20 over 25. So here's the proportion. Solve to find out what b has to equal for this one's radius. You know it'll be greater than 16. And then finally for number 12, surface area. So we know that the surface area ratio is the same as these linear ratio over here, but then you have to square it because it's surface area. If it had been volume, remember we cubed it, but that one didn't show up on this test. So I put the small surface area, which is unknown, over the large surface area, which we do know, 1240. And then the small length over the greater length, but I have to square those. Now before I square them, I can simplify what's in parentheses there. 7/14 is the same as 1/2. So now, square this 1/2 and then solve for the surface area. Okay? and the units will be feet squared. So solve for the surface area using this ratio right here. Well, hopefully that helped you and made that pretty simple to take this test. Now go do so.